thank you all for joining. So today we are starting on data visualization in R using ggplot2 is a package in R. So today, let me first of all just bring you up to speed with where we are at the moment. So as of today, we are at a review, that is session 4, 18th September, session 4, that is a review of data visualization using ggplot2. So my colleagues, Ashna, Ludovic, and Chioma have already covered aspects of data cleaning, tidying the data, and data wrangling tidier. And so for today, before we go to any advanced, techniques of plotting using ggplot2, I will start first of all just review of what ggplot2 is and how we can actually use it to make visualization for it. Because at the end of the day, we need visualization to actually create narratives from the data that we have, okay? And it just enables the audience or the target people to understand what the data is all about in an easy way. So let me, I have a few slides. I will start sharing. Then the other component of my materials will be on an HTML. So over the next 3 sessions, we will look at a review of ggplot2, that is today, and that will also cover basic visualization. Then our session number 5, that will cover advanced visualization part 1, and then advanced visualization part 2. Okay, so we are just trying to look at ways that we can communicate or derive insights from the data that we have. And the data that we will be using will still be the HIV data updated. And moving on now, we'll just build on the concepts that Ashna and Ludovic covered, whereby they did the cleaning, they did the manipulation of that data. So we'll just build on those concepts. For now, we'll just do visualization. So the objective of this is to just learn how to create powerful visualizations using ggplot2. And we'll understand the grammar of graphics and create best. First of all, the first element is just in the review, we just look at basic visualization. Then we can look at how you can customize and save plots for reports and presentations. And definitely the prerequisite is what we've been doing, just basic R knowledge, and at least some idea of how to deal with the data frames. And this has already been covered in the previous sessions. Then, so what is ggplot? I can see this. Frank is asking whether there is ggplot1. I don't think there's ggplot1, but there is ggplot. I think that's right, Ashna. There is ggplot, but there is no ggplot1.
Yeah, I think that's exactly it, because the actual the function is called ggplot, but why the package is ggplot2 and not ggplot1 is a little bit confusing, actually.
Yeah, I actually think the ggplot2 is an improved version of the ggplot that used to be there. I remember there was a time I used it, but it's a long time ago. So I think ggplot2 is an improvement of ggplot1. So what is this ggplot2 that you're talking about? ggplot2 is actually a package for creating flexible and professional visualizations from your data. okay? And it is actually part of what we call the tidyverse ecosystem. Remember, Ashna showed us that if you install tidyverse, it comes also with ggplot2 and other packages that are used in data wrangling and tidying of the data. Okay, so it's part of that. But you can also install it separately, ggplot2 as a separate package, or tidyverse as a separate package. Okay, and GG actually means the gram of graphics. Okay, and it's actually what we call a layered way of building graphics, because now you build these graphics layer by layer. You add layers on top of the other. Okay, and we'll see what these layers actually constitute. So and the easiest way to get this ggplot2 is actually to install the package tidyverse. Just in your console, you can just type install the packages tidyverse, or you can just call ggplot2 the package separately, just install for you. So what are the principles of effective data visualization? How do you know that whatever type of visualization you use, you will communicate what is intended? So there are basically 4 principles when it comes to effective data visualization. The first one is clarity. You're supposed to simplify complex data, okay? And the main message has to be highlighted, and it has to be easier for the target audience to understand. So clarity is number 1. Number 2, it has to be accuracy, okay? Please use scales that represent data, okay? I remember, as we'll see later, as we proceed on with the visualization practice, you'll see that there's some scales. If you have decimal points, data that has decimal points like 1.0 times 10 to the power negative 6, and the following number is 1.2 times 10 to the negative 6. See, if you plot this, and maybe your other axis is in millions, you'll find that you may end up even not seeing the plot, because it will just be like a 0 on the x-axis, but we'll see this later. So please use scales and try to represent the data as accurately as possible. Then consistency. Color schemes and formats, just have consistent formats in your visualization, and visual styles, okay? And I've seen this actually comes into play when people are naming things like axis labels and titles. You find that they use very funny fonts with colors that may really even overshadow the colors of the actual plots. So at least you should be consistent in how you do this. Make sure the color schemes stand out, and the information that is intended, that you intend to communicate, is actually comes out clearly. So consistency is key. Then relevance. Relevance, you must know what you need to communicate from that data, okay? Don't just plot everything. Just know what information you need to actually communicate, and then you'll know what kind of plots you will need to use and how many, okay? Then I think that's about the principles of effective data visualization. Always carry this with you: clarity, accuracy, consistency, and relevance. So remember what I said about ggplot2 being layered visualization. You build on layers upon layers of that actual visualization, okay? So we have these building blocks when it comes to ggplot. The first one is the data. The elements of the data that you want to plot. That is the first building block. This one has to be there, because as we'll be using ggplot, you must define where your data is, or what data you're going to plot. Number 2, aesthetics, okay? So you have to map the data to aesthetics attributes like x-axis, y-axis. If you're using markers, how do you want to fill those markers? What is the size? Okay. Should they be transparent and all those kind of things? Okay. Then we have geometrics. Okay. Geometrics. If you want to actually show distribution, what kind of a plot should you use? Okay. So that is that comes under the building block of geometrics. Okay. That is if whether you want to do a point plot, a scatter plot, that is whether you want to do a line plot, histogram, bar, box, violin, and all those kind of plots. Okay, you just know which kind of or which type of data visualization will actually communicate clearly what you want. Okay. Then you may find that there comes a time when you would like to actually juxtapose two plots so that you can create comparison between the different plots. So you can think of a building block which is called facets. We'll look also at facets, and when they see how it actually works. Then things like statistics, that is a binning, smoothing of curves, introducing fittings in these plots, so that you can actually derive more insights from those plots and etc. So that's the building block called statistics. Then we also have coordinates. Sorry, there's a typo here. It's not supposed to be coordinated. It's supposed to be coordinates. So how do you use the limits, the axis limits, so that you can actually capture the data in a more aesthetically pleasing way. So that is a building block called coordinates. Then there are themes. Themes has no link to the data that you'll be using, but it's just one way you can improve appearance of your visualization. So these are the building blocks. Anytime you will be adding a building block to that ggplot, know that you'll be in any of these: data, aesthetics, geometrics, facets, statistics, coordinates, and themes. Okay, and only theme is not related to that data that you'll be plotting. Then we have some types of visualizations that we normally use. The common ones are scatter plots, where you want to display the relationship between two continuous variables, and you want to plot them on a Cartesian plane. That is just the X and Y axis. Then you can have bar plots. That is very good when you're comparing categorical variables and their frequencies. Then we can have line plots. Line plots, we can use them to show trends over time, or continuous variable, which you can actually connect them using line segments. Then there comes a time when you would like to check on the distribution of a continuous variable. You want to know the mean. You want to know the maximum value. If there are any outliers, you want to know the quartiles. Then a box plot comes in handy. Okay. Then we can also have histograms. Histograms, you can use this to actually take the frequency distribution of a continuous variable. Okay. So check the difference between histogram and bar plots. Bar plots is good when you actually want to compare categorical variables. Histograms, you can just check the frequency distribution of a continuous variable. Then I think that is just a brief, simplified overview of ggplot. So in case of any question, please reach out to us, and we will get back to you. So let me also share. That's not the end. Sorry, let me see. Yes. These are more detailed notes that we will be sharing with you after today's session. So we have very helpful references that you can also use when you would like to do more practice. There's a book which is called Epidemics. It's purely about models and visualization of data using R. It's called Epidemics. It's a very nice book. And also we have Epidemiologist R handbook. It's also very good, which has a lot of, and we'll also form part of our other sessions will also be we'll actually borrow examples from epidemiologist R handbook. So it's a very good book. So I'll not repeat types of visualization because we have already covered that. So definitely the first thing will also be to load your packages that you need. But shortly, we'll just do this in practice. Then, as always, import your data. You can clean the data as we saw in our previous 2 sessions. Okay. Then you can actually do the ggplot. And remember, when you're adding layers in a ggplot, we always use the plus symbol. Okay. So what this does, it kind of opens up ways of adding layers. So that plus symbol will always be very important. The layers and the building blocks, you can also always link them up using that plus. Okay. We'll just see that shortly for those who have never done visualization in this. Okay. And there are so many different types of visualization using ggplot. You can use histogram, and the way we add this layer of geometric is using geom histogram. You can add histogram. If it's a bar chart, you can either call it as a geom bar or a geom call. Box plots, we'll look at this shortly in practice. Geom box plot, points, it can be geom point, which will do for you a scatter plot. If it's a line, if it's trend lines, adding trend lines to point plot, you can use a geom smooth. Then you can choose you can choose the algorithm to use at that point, because you kind of be doing a fitting of that data. Okay, so remember, since it's a layered kind of visualization, remember, if you do histogram, then you do bar charts by adding that geometric. So the bar chart will come on top of the histogram. So it's advisable that you know what needs to come on top of the other. Okay, because it's a layered approach. Okay, you're very welcome, Abraham, for this training. So today we're just doing a review of data visualization in R using ggplot. So you're very welcome, and please let's learn together. Okay, so the other things that that we'll also look at, mapping data to the plot. We can always use the IS function. Okay. Then let's see. These are just examples of the plots. You can have the scatter plot. You can have this kind of a box plot. We'll see how you can add aesthetics to this kind of plots. You can have histograms. Now plot aesthetics. You see this these 3 plots I've shown here. They're not really aesthetically pleasing because they lack color, they lack style. But all this can still be added. You can have user-defined colors, or you can let the color be determined by the kind of data that you have. So some of the options that we have for aesthetics will be things like shape. You can have feel. If you're having markers or the bar plots, what do you want to be the color of those bar plots? Okay, you can either define the colors manually, or you can let the data that you have determine the color that will be used to fill. Okay, you can also have the size. This gives you things to do with the point size if it's a marker, a line thickness if it's a case of a line plot. You can also have another element of aesthetic which is called alpha. Alpha is basically, if you assign alpha a value equals to 1, that will make that point to be opaque. If it's 0, then it's invisible. It becomes the color is almost, you can say it's white. So it's and in case you have a white background, then it becomes invisible. Then we can have bin width. That is we can use it for histograms. We can have also width for bar plots. Line type, when you're having line plots, you can either determine whether you want it to be solid dashed or dotted and etc. Okay. Then there are actually two ways to plot to actually determine color of a given plot. The first one we can actually assign a static value where you can actually define the color that you want explicitly and say that, for example, I want my color to be blue, for example. Okay, but the disadvantage of this is that if you have several categories of data, you have to define for each and every category that color. Okay, for each their own color. So it's a bit manual and actually may take a lot of time, and it's prone to making mistakes. So, but anyway, you can also let the data, the column of the data, to help you assign part of the aesthetics. Okay. So we'll look at that shortly. Then also these are just forms part of the aesthetics that we will look at. How a geom point, how do you add aesthetics to this? How do you add color? How do you use alpha if you want it to be opaque, you want to be invisible, and etc. Okay. Then this is just part of the line fit. Then another very, very important part of the building blocks of ggplot is what we call ggplot themes, coordinates, facets, and axis labels. These are important because they actually help what is plotted. They actually help in communicating better what has already been plotted in that chart. Because if you don't have a label, the target audience may not even know what you actually plotted. So axes are important. Coordinates are very important. Okay, it's not a must. You can see for such a plot which is here, if my axis, my VL, the y-axis was from 0 up to, let's say, 1 million, you can see that this one will almost be close to the x-axis. So coordinates will be important because we may need to actually zoom in to what is important and what has been plotted for a particular chart. Okay. Then facets we'll use them when you want to make a comparison between two different categories of plots. Then themes, as you saw earlier, themes is the only part of the building block that is not linked to the data that you're plotting. So for this, there are quite a number of themes that you can use, but they just use to actually create more aesthetically pleasing plots. Okay. So, but in general, we'll just look at how we have used ggplot to actually make a number of visualizations. I may also mention that ggplot2 is actually a very good foundation for exploring other plotting options. I know in base R there used to be what we call the ggplots, but R is supporting ggplots because they also wanted to encourage users to use ggplot2. Okay. So I think let me know if you have any questions. Otherwise, we'll just now jump into our R studio and do a little bit of practice. So I can see there's a message in the chat. Oh, thank you. Thanks so much, Virginia. So any questions so far? And I know Damilola mentioned last week that this was his first experience with this. So we highly encourage you to look at our previous training where we covered a number of these concepts. But if you have any problem with that, please don't hesitate to reach out to us. Okay. So let me share. Let me share my screen. Let's see shortly. 1 second. Okay, so I've opened my my R Studio. So remember, you can install ggplot2, or you can just install tidyverse, because it's the one that we will be using. So ggplot2, and for my case, because we are using the HIV data updated, it's an XLSX file. It's a Microsoft spreadsheet. So for that, I will need to install read Excel. This one is to read Excel files, and it's the one which actually contains read Excel. Okay, so read Excel, I've given it the path to my file. So if I run this, so it has actually loaded for me. It has loaded for me my data, and if I scroll to my environmental my environment pane and click on this, you can see the data which has about 15 columns: the ID, age, gender, occupation, HIV, and all that. Okay. My colleagues Ashna and Ludovic actually covered how some of the manipulation of this data is done, and so we'll just build on that. We'll just now try to visualize after the cleaning what actually happens. So if you'd like to look at the structure of the data, you can use line 11 str to look at the structure. The head, this will actually show you a number of rows. I think a number of rows. So this is and it shows you also the data type of that particular column. Then now, so next, remember like the HIV data that we have here. So let me just go back to my HIV data. The HIV data that we have here, you can see it's actually zeros and ones. So a person who is HIV positive is 1. A person who is HIV negative is 0. Okay, so we can try to actually record this. These are what we call categorical variables. They're just categories of you're either HIV positive or HIV negative. So those are two categories. So we can look for ways of again modifying this. Same as the gender. You can see the gender is 1, 2, 1, 2, 1, 2, 1, 2, and it is. So we are assuming that's just male and female. Then you can also see the age. The age is they're just numerical values, but so that we can be able to actually visualize aspects to do with the age, we can try to group these ages together. Okay, so I think those are at least for today. These are the only two manipulations we're going to do to our data. Okay, then next time how we can actually do more manipulation. Okay, so we can actually create a column which is called the HIV cat, which just means a HIV category, but you can call it anything that. But I just felt that I would just call it HIV category. NA means that you create it, but so if we create it, you can see that if you scroll towards the end, it will just create a HIV column, but we'll just fill it with NA, okay? But that's not what we want. We want that that HIV category, anywhere there's a 0, we want it to be assigned the string negative. Anywhere there's 1, we want that to be assigned positive, okay? So we can now update the NA so that now instead of just having NA, now it is negative and positive, okay? Then we will also do the same thing to the gender. We can create a column that is HIV gender. We can initially we can assign it NA, but we can populate that now. Instead of NA, we populate it with, if it's 1, we can populate that with female. If it's 2, populate that with male, okay? So, and if we, oh, unknown, sorry, I did not run line 23. So now it's there. So now we have 17 variables, and instead of the 15 now, because we've added 2 extra columns, that is HIV category and HIV gender. So anyone who was 1, becomes female, and 2 is male, okay? There are also other ways that if some of the, if a column is not a factor, you can convert them to factors as well. That is, you can use as factor. So you can mutate those columns to be as factors. This is also another way that we can actually do it. Then we can remove, because age can be a very useful element or data in our visualization. So in case there is any row with missing edges, what we are doing, we can actually just remove them so that we have yes, so that we can just remove any rows that has any missing edge. Then remember now what you've done for gender and HIV category. Those were just trying to record categorical variables. But now we can also record what you're calling the continuous variables. That is the age. We want to group the ages. If you're 0 to 14, 15 to 24, 25 to 49, 50 to 59, 60 plus, we want just to group you in a given category. And we use a function which is called cut. So what this one does, this part of line 47, what it will do, to just create a column that is called HIV cut. And if you fall in any of these, you'll be assigned to a respective, category. And the good thing about this, at the end of the day, you can use the count function to actually count how many people were in this particular age group, okay? So let's do this again. And this now, it means that our data now has about 20 variables. So that we'll also have age cut as well for age category, okay? Then, now that we have done all these preparations, and this preparation, there are other techniques you can actually see in the previous sessions that that was done. So this just provides you with extra options or choices of how you can manipulate the data in the way that you actually that suits you. Okay. So now we have, at least for now, we have cleaned the data the way we want. So remember the 7 building blocks of ggplot. The first one is data. You must define where your data is, okay, or what you actually intend to plot. So in this case, I want to plot HIV data, and HIV data that will be plotted is this one here. the one that we have already cleaned, okay? Cleaned or manipulated. Added whatever we want, done manipulations, mutated, and all that, okay? Then, so it means that what, if I just call, because we'll be calling the ggplot function, if I just put in the data, please observe what happens in my plot pane here on your bottom right of your screen. You can see that there's something which looks gray because what we've actually done, we have just given our intention that we want to plot, and we want to plot HIV data, but we have not defined what we want to be on our axis. We have not defined what kind of visualizations that we want and all that, okay? So just putting the data is not enough, okay? But suppose, because I know from my data, I can see that I have CD4 count and I have the viral load, okay? Suppose I just want to plot CD4 count versus the VL, okay? What do I do? First of all, we can actually define components of our axis in what we call IS, short for aesthetics, okay? And you can say that mapping equals to aesthetics. What we want to be on the x-axis is x equals to CD4, and y equals to the viral load, okay? Y equals to the viral load. This is still not enough. Even if I run this is not enough because what has actually happened now is that it has just shown me that, okay, your x-axis will be the CD4 count, your y-axis will be the viral load, but still, I have not chosen the next building block, okay? I may have chosen the coordinates, yes, but I have not chosen the kind of a geometry that I want, okay? And that's why now, once I've done the data, I've set my axis, I need now to select the kind of geometry that I would want. And that's why we said, remember what we said in the just a few moments ago is that if you want to add building blocks in a ggplot, we use the plus, okay? So in this case now, if I want to do a scatter plot, I know scatter plots are just points. We can use the geom point. So this one plus geom point, okay? Geom point for a scatter plot. So now if we run it, you can see that now, besides just having the axis and the blank canvas, now we also have some data points which have been plotted, okay? And in your console on the bottom left, you can see that it's saying it contains missing values that have been left out. It's because if you look at HIV in a HIV data set, that is the CD4 count at VL, the viral load, you can see that people who are negative do not have any data associated with the CD4 count or the viral load. A person who is HIV positive, that's when you can have the CD4 count or the viral load. So the rest will just be omitted. So what has been plotted here, we can actually conclude these are just the HIV positive people are the ones whose viral load and CD4 count has been plotted. Then we can also have a histogram. I'll come back to line 63. We can also have a histogram. For histogram, because this one will just show the frequency, we can just define x equals to CD4 count, but we want the histogram. So we can still define the geometry by plus geom histogram. So if we run this, you can see that again, it plots for me a CD4 count on the x-axis. Then on the y-axis, we actually have the counts. But it's not really an appealing plot because It's just dull. We'll see how we can improve the aesthetics shortly. Then in line 64, we can also do a box plot. A box plot whereby we would like to know we would like to know what are the outliers in that particular data? What are the can we actually be able to see the mean, the median, the maximum values in that in the CD4 count? Are we able to do that? Yes, we can. So we can do this. We can run line 64 because it's again it's ggplot HIV data. You must define the data that you want to plot from. Then what do you want to have on the x-axis? Because I would like to actually look at these statistical elements for both the gender separately. So I can define my x-axis. I'll have it as HIV gender. Remember, we already did the recording for the HIV gender. So what will be on the y-axis will actually be the CD4 count, and we can look at the distribution or the statistical elements of the CD4 count for each gender. So if I do this, first of all, let me, and again, if I just run that one, because I've not chosen the kind of geometry that I want, you can see that, yes, y-axis is CD4 count. The x-axis, there's HIV gender. There's also female and male, but there's nothing else, okay? So I can select, let me first of all remove what we have inside here. Then we'll actually see what they do. So let me run this. So what has actually happened, it has plotted for us, we now have a box plot for female and male, and the CD4 count, we can get the maximum, we can get the minimum. If there are any outliers, you can see the third quartile, the first quartile, the 50% quartile. We can see whether there's any outlier and all that. Okay. But then we can try to improve the color of this box plot. And if I just use this argument, color equals to HIV. And remember, you have to call this from the IS aesthetic function so that it can, ggplot will interpret that you want to use HIV gender for color. So if we run this, what we have is, it has just plotted for us. And further, what it has actually done, it has tried to categorize these genders with color. So you can see for male, now it becomes this bluish, light bluish color. And for female, it's this light reddish color, okay? But for a box plot, because you may not know where the mean or the median is, there's also that option of what we call the notch equals to true. If you use the notch equals to true, what actually happens is that where is the mean or the median, that's where you have your notch there, okay? So this actually falls, is actually part of some of the aesthetics that you can be adding to your plots to make them more pleasing, okay? Remember what I said about ggplot being a layered visualization. Now you can see in line 66, we can also add jitter, okay? On top of our box plots, we want to see how are these CD4 counts distributed visually. How can we visualize the distribution of this CD4 count for each gender? So we can do geom jitter. Geom jitter is also another geometry of visualization that can be used. And in this case, I would like the color. I would like the color to be black. Yes. What do I want the size of the jitters to be? I want the size to be around 0.8, but I also want the transparency of this jitter to be around 0.3 because I don't know if I plot the jitters on top of another plot, I don't want it to overshadow my main plot. Okay. So let's see. Now that we can add another layer to this, so we have to do the plus at the end of line 65. So plus the jitter now. So, and if we run this, you see that now on top of my box plot, what it has done, it has added the jitters, which can show the distribution of those CD4 counts for each gender. Now, for argument's sake, let us increase the size of the jitters to be something like 1, and this one to be less transparent, to be something like 8, and see. Let's see what happens. So if I run this, you can see that now the size of these jitters are much larger. That's one thing. The other thing, they are less transparent. They are more opaque. Okay. Now, I would like also to do something else. I would like to, let me remove that. And let us do the box plot. Let us do the box plot after the jitter, and we see what happens. You can see now, the way it is at the moment is that the jitter is on top of the box plots. So if we run this, you can see that now it is the box plot which is on top of the jitter points. Okay, so that is why I was saying that ggplot is a layered. So you're adding layers on top of one another, and it's very important to know even if you're adding a different type of geometry, what do you intend to communicate? Because as it is at the moment, it will be a bit confusing because some of my geom jitter is being obstructed by the box plot. So that order of how you do it is actually very important. Okay, I see. What if you replace color equals gender? Yes, that will be very something we can actually try. Let me revert, or rather, let me just do fill, and we see fill equals to HIV gender, and we see what happens. Wonderful. You can see also now on top of using color equals to HIV gender, we can also have fill equals to HIV gender, and our box plots are now filled with with respective colors for female and male. Okay, let me also revert back to the order that we had previously. Because I can see my jitter points, and also let me reduce, and we have it the way it was. Let's say also we have just a bit as 0.1. Let's look at how it is. Oh, they are more faint now. Let's go back to 0.3. Wonderful. And now I have never tried jitter, but let's see if I use IS and color instead of black. Instead of it being static, let us assign it to the color using the column, and we see. Let's see whether it will work. I've never tried that. So if we do so, yes, you can see that now. Maybe I can make it a bit opaque. So you can see now also besides just having the color black, which was static, we can now define, we can now assign the color using the column value, in this case, HIV gender. Okay. Yeah, thank you, Ashna, for that addition. Okay. Then we also have, I think we did the histogram. There's also other kind of a plot of a geometry, which is called a violin plot. Let's see. Again, a violin plot, you define the data. For the x-axis, I would like my CD4 count and y to be the viral load. But then, let's see. Even without the color definition, let's see what actually happens. So you can see it's just something that is a very dull plot, but if we use the color, you can see that now. The thing is, with violin plot, at this point, you can see that for male and female, they're actually on top of one another. But we'll see shortly how we can use facets to actually ensure that you can have them side by side. Okay. Just hold on to that thought for the violins. We'll come back to it shortly. Then also there's another way now that always comes in handy when you're using ggplot. You can actually assign a variable or a name to your plot. In this case, line 81, you can say that I want my ggplot to be given the letter P, to be assigned P. Then whatever layer or whatever blocks that you'll be adding later, you just need to call P and not the whole phrase, like the one in line 51. So let's see. I can just run this one. And the thing is, this one now, you can see P now appears in my environment. If I want to visualize P, I can just run P on its own. But now it's empty because what I've done, X is HIV gender. Then I want to fill with the HIV category, but I have not defined what kind of geometry I want. So in this case, let me first of all remove this argument there. So if I run now line 83, so it will just pick P plus geom. Okay, but sorry, P plus geom bar, and it gives me a bar plot. Okay, now there was that option which says the position equals to identity. That is always an argument in bar plots, which means that you would like to have this side by side. Okay, the way it is at the moment, it is stacked. Negative is stacked on top of the positive for female, and the same thing for male. But if I add this argument that position equals to identity, what it means is that it will now, let me just run it from the beginning. Just supposed to be one in front of the other. Let's look at stack. Because stack is also another option for the geometry. That is stack. Then let's look at, so we have let's look at dodge. So we have 3 options when it comes to the position of the bars in bar plot. There is identity. So I can write it here. There is identity. There's also dodge and what you call stack. If you want to have it on top of the other. So let's look at this. I want to have a Dodge. So what Dodge has done is actually placed it side by side. That is Dodge. Identity is the one we have one in front of the other. So you can have negative, then positive on top of the negatives. Okay, it's actually what we had previously. That is identity. If you check identity, that gives you, yeah, one on top of the other or in front of the other. Stack ensures that yeah, I think stack and the identity are almost similar to one another. Let's see. If you do stack now, sorry. If you do stack, yeah, that. Okay. Then there's also, you can also have an option of filling with age, category, all this can actually be added as well. What we have here, let's see, if we do, this one is, okay, this is a question. If you do geom bar position, you can feel static. Wonderful. Yes, yes, yes. That's a very good option again. We can add. Thank you so much, Ashna. So you can have a position equals to field. Then you can now start equals to identity. Yes. Let's see how that will be. Beyond first layer request.
Oh, whoops. I think this one requires some count as well as a Y value.
Oh, yeah. It needs some Y value. Let's see, HIV cut. Let's see if we do Y equals to VR, whether it helps us in that. Yes. In this case, field position is field start equals to identity. Suppose instead of identity, we do stack. We see what gives us. Stack. Can't find the start code.
Maybe I imagined this example.
So
All
it's
good, all good. It might just be
it,
for different types of data.
yeah, it seems like stack.
Oh, that makes,
Actually, you can check for us whether start only takes in identity only.
I think so.
Yeah, only.
Yes.
Yeah. I can see Ludovic is asking why shows only positive, and that's why non-negatives. I see. We have in line 81, we also have another field here that is taking into account the HIV category. Let's remove this and we see whether now it will also plot the rest. Now it's black. Now it's black and it seems like it is stacked because all of them actually sum up to 100.
Yeah. Sorry, Duncan. Is it not because of the viral load in y-axis? So we have X for HIV gender, and then Y is viral load VL.
Yeah.
So it means our output will only be for those who are HIV positive. So that's why we only see.
Very right, actually. Yeah. we know, yeah, it's true. It's true. Actually, it's actually correct. Thank you,
Oh,
Ludovic.
yeah, yeah, yeah. That makes sense.
Yeah, you're filling with HIV category, and the y-axis is viral load. So definitely will
You
not
do
have the
age
negatives.
age groups instead of VL? Or I guess that's something that, yeah, because they're all positive. Perhaps age, yeah, age cat or
Oh yeah, let's. So we see, we do HIV cut here.
yeah, and then fill equals age cat maybe.
Physical age cut. Let's see that. This one should be interesting. Okay.
Oh, I guess because they're all positive HIV.
Then the HIV gender, HIV cut with the age. Suppose
Or maybe just HIV cat, yeah.
HIV, let's see, HIV cut. But now, our axis is category. That's why we have HIV negative here and positive here. So it becomes confusing. But, let's see. But I believe our plot was okay because as Ludovic said that if you're plotting the y-axis as a viral load, then definitely will not have the negative, will not have the red part. We'll just have the positives only. Interesting. So it's actually part of the learning process because one actually has to understand how your data looks like, or what you actually really need to plot. Very interesting. Yeah. So other things that we can actually add to our geometry, we can add labels. You can add the title. You can now specifically edit the names, the axis labels. You can name. You can also have the fill. Let's see what this one will be. In this case, you can actually plot the age groups. X equals to age category. Then this is just a bar plot again. What you want to be is the color, the outline of the bar will be black. Then the filling will be determined by the age category. Then now you can explicitly give the name of the title, the x-axis, the y-axis, and also for the what should be filled, the name of the field. So and let's see if we remove line 90, you can see that instead of having age groups as the name of that legend, it will be age cut. It actually becomes a factor age cut, but this one does not look pleasing or appealing when you would like to give a presentation using this chart. So that's why it is important that we also give the name of or a user-defined label for the legend as well. So that's why fill comes in, so that you can have age groups that defines the ages that are actually being plotted. Okay. So far up to this point, we have seen that the colors that we have been using, we've been setting them using the data which is available. Okay. But it is also possible to set a static value where you specifically define the color of that geometry, specifically define the color of that marker. And so instead, like what we had here, like for this jitter, the one that we look for the jitter line 66, whereby the color of that jitter is determined by the color by the HIV gender column. Now you can actually define the actual color that you want. Okay, so like in this case, if I want to do a scatter plot for the same like the one we did for CD4 versus the viral load, but now in this case, the color of that scatter point has been defined as red. Okay, and R has a very beautiful way of showing you the color that you've chosen. As long as it's in its catalog, if you type the word red, it just highlights the whole word with red, so that you know that you will be plotting with red. Okay, and the same thing as you can add the size. You can add alpha, that is the transparency. Let's increase the opaqueness to 8, so that and the size, maybe let's do just 2.6 and see how large you can get. Yeah, they become large, etc. Okay, the same thing will be for something like histogram. You can now define the fill. You can define the color, the outline of the histogram. You can define the band, the bin width, and etc. Okay, so in this case, I would like to look at the distribution of the CD4 count. And in this case, I can have the color of my outline as blue. Let me just, well, let's change this to green. Sorry. Green. You can see green again highlights. So if we run this, it means that the outline is green. The field is black. Let's see. Let's just use the field as blue. And this, but the alpha is true. Just play around with some of this. The field now becomes blue, and it's a bit opaque. Okay. Bin width is about 20. Let's do 40. 40 becomes much. The bins become larger. Okay. If you want it to be maybe size 5, we can look at the plot how it looks like. They become much thinner, but also it gives room to areas where that value is very low, but it's non-existent. Okay. So all this we can also add the trend lines. Trend lines can be added using geom-smooth. Geom-smooth is also part of the geometry, and as always, you can add it using a plus. It's part of the geometry. You have to choose the method. In this case, we chose it's a linear model, so it will just be a straight line. So on top of your scatter plot, where you have you're plotting CD4 versus VL, and you're defining the color to be HIV category. You may also want to just have a line that fits through that data. Sorry, I need to run it together. Yes, so it actually fits. It actually just puts a trend line of that, so that it actually shows as the CD4 counts increase, so does the VL reduce. This is a question. Look at this. Can you yes, let's do that for the histogram. Histogram. Yes, let's actually add. Let's add the density. Yeah, that actually makes more sense when you're doing the histogram. And this, because it Oh, sorry. I've added two. So this one becomes then equals to 1. Let's see the bin width equals to geom density. Color equals to, let me add about 20. The bin width to be 20. Uh,
Maybe this is another one I imagined. Never mind.
it's yeah, I also thought it would be something like a line.
Yeah.
It actually follows like a normal distribution of the bars. Because yeah.
Yeah, strange. I always thought geom density, yeah, exactly, would plot a little trend line across.
Yeah, exactly. I also think that or let's do this. Let's remove the histogram. Will this make sense to do the density? Yeah.
Oh yeah, there we go. There it is.
Yeah.
Strange.
But I see Ashna. You see, um, the values of the density are so small because this is like
Ah, that's why.
1/1000th of
Yes, yes, yes.
and this one is 5 times 10 to -4. So if we actually return the histogram, the count values are quite high or greater than
Right.
density. So to just be like a 0.
Yeah.
Yeah, so,
Disappears.
so this actually brings to the point which I mentioned earlier about the coordinates.
Yes.
Yeah. Some values normally disappear. So, and you'll find that you may need now to take the log plots of the density so that they can actually appear on the chart.
Interesting.
Yeah, very interesting. So that's it. So you have to know. So we actually have to know whether, or we have to decide whether to have them as separate plots and look at ways of linking up the explanation of what you're visualizing in case of the two. Then what else? Facet grids. Facet grids. These are when, as I mentioned earlier, or now let's go back to our violin plot. The violin plot that we had here, you saw that when I plotted the violin plot here, what actually happened was that the male was on top of the female, that plot. But now, facets, because it's possible now to have them side by side, facets actually helps us to achieve that, okay? So for example, I'll just do the violin plot again, this one here. If I plot it, and the fill, in this case, is HIV gender, but now I would like to separate these two. If I separate these two, what actually happens is that I can use a facet trap. There's facet trap and there's facet grid. Facet grid is normally when you have two variables that you want to actually have or to actually compare. Then for facet trap, let's see what happens. If I do this, so it means that I will be having two plots that can be used for comparison. That is male and female. Then, so, but there's this now. Okay, very good. Is a question in the chat? Let me see. How do you test normality? Okay, yeah. Checking the whether a given numerical variable is normally distributed. Yeah. Thank you, Ashna. So this is what I was talking about. Coordinates. You can have coordinates in a way. Let's see, like the y-axis in this case, we have defined it to be the limit from 0 up to 6,000. So if we comment that out and we run this, what actually happens? It doesn't have any difference in this case, but we'll see next time in an example why these limits are very important. Then coordinates flip, we have just inverted the axis. So they appear the way they appear, but you cannot just change them by commenting out that code flip part. Basically, facet grid, that's the main purpose. You can use it to juxtapose two charts, whether it's a category of the same variable that you want to investigate. You can use facet grids. And remember, there's this symbol here which is tilde. Tilde is very important. It has to be there. So it is tilde and the variable that you actually want to compare. So that's very important for the facet trap. Then in addition, we can also have facet grid where you'll have the HIV gender and also the HIV category. You want to compare these two. So if it's two variables, you can use facet grid. So facet grid, what you do, on your y-axis, what you have on the y-axis will be the gender. So like in this case, you have you can see on your right, on your bottom right, that pane, the right hand side, you have the gender, that is female and male. And at the bottom there on the x-axis, we have the age distribution of each HIV status. So you have the negative and the positive, then you have 0 up to 75, 0 up to 75 for the negative, 0 up to 75 for. And it can be interesting also to also use color. Let's say S field equals to age. Let's try. I'm just thinking here wide. Use edge cut for the color. Let's see what it will give us. Group. Okay, let's remove this color and this one. This one works. Yes, but that's the color. Fill equals to age. That gives the color of the it's so colorful. Yeah, but yeah, so facet grids and facet wraps come in really handy. Also, I think you can also define the colors manually, which we saw earlier, where you actually define the scales of the color. And if you have more than one category, you can pass them as a vector. They don't find this to be too much work. Why don't you just use the column to define the color for you? So yeah, that gives us that for us. So we have defined there's green. So and because you're plotting the CD4 count versus viral load, we'll not see the forest green, because the forest green is for the negatives. Okay. Then you can just put your labels again. You'll have your labels there, the size of the points and etc. And for the themes, please note that now we are also defining the themes. You can have the theme black, white, you can have the theme gray, and there are so many, so it will just depend on what actually pleases you. Okay. So I would like to stop there for today. We can meet next time. We can still try to look at some of the different plots. So please check on our Art of Fun Club, or we'll just post something for fun, which you will try during your free time. Then next week, we can review that, plus the exercise. We'll also upload it tomorrow. you can try during your free time. Okay. So otherwise, in case of any question, please reach out to us. Or I don't know if there's any question, you can ask us. Ashna, would you like to add anything on top of that?
Nothing from me. No, this is a great comprehensive overview. And yeah, I just encourage people to play around with ggplot. I think this is one of ours. The visualization is one of ours biggest strengths because of how much you can customize these plots. So the more you play around, the more you'll find out.
Yeah, exactly. Exactly. I agreed. Ludovic, would you like to add anything on top of that?
Actually, not really.
Mm.
Thank you for the presentation. I think I came a little bit late, but okay, I usually remember that at least you should always remember the three important things. You should have your data and then the mapping aesthetics and then the type of geom that you want to plot. And then later on, you can try to manipulate other things like how you want the heading to be, etc. Otherwise, nice session.
Yeah, thank you. Thanks so much. Wonderful. So if you have any question, please, you can always post on our group. But otherwise, we'll still meet next week for Art for Fun Club session so that we can look at, around ggplot2 and try to play around with some of the options that we have and see what we can actually come up with.
Okay, Duncan, thank you. It was a very great session, and I see today we have new other names compared to the ones that we had for the previous weeks. So if it's your first time for you to join the session today, just note that we're on the session 4, and take the time to, I think I sent a certain message during the session. Go to the platform, register to the course, and take the course whereby you'll find all the content that our facilitators has been doing since the beginning of the sessions. And remember to take the quizzes, and then keep on following up for the other upcoming sessions, and finally will be able to earn your certificate. Otherwise, thank you very much, Duncan, Ashna, and Ludovic. I really enjoyed it. I hope everyone who had a time to follow up enjoyed the session. Thank you very much, and I'll see you all next week.
Thank you. See you next week. Bye.
Thank you. See you all.
right.
There's a question in the chat. Is this course free? Yes, Ludovic, this course
Right.
is completely free of charge. You
Okay,
just need
thank
to
you.
register. Yes.
Okay.
So you can all share with your networks. This course is free of charge, and at the end of it, you are going to have a certificate upon completion and passing all the quizzes. Yeah.